Hello everyone, welcome to Shivam's classes. In today's lecture, we are going to discuss problem number 7, 8, 9 and 10 of chapter 6. In previous classes, we had discussed problem number from 1 to 6. Now in today's class, we are going to discuss problem number 7 first. So let's start the class. So let's see the problem first. What is given in this problem is prove that the sum of the squares of the sides of a rhombus is equal to the sum of the squares of the diagonals. So first of all, we need to understand what is the rhombus. Okay. Once we understand the rhombus, then we will understand the sides will be of equal length and also the diagonals also will be of equal length. So let's first draw a rhombus and try to understand that property or its property. Alright. So first of all, let's take a side which is this. Alright. And then let's take a copy of it as well, because the size will be same, right? So right. Taken a copy of it. So and then let's rotate it by say 90 degrees. Now I have got another side of the rhombus. Now let's take another copy of it and then move this side over here. Let's take another copy of it and move this side over here. Now let's draw the diagonals. Now let's call it A, B, C and D. So here the sides are AD, AB, DC and BC, and the diagonals are AC and ED. So what we know, if we know the properties of rhombus, first the sides will be of equal length. So let's say if this side is of length A, this will be also of length A, this will be of length A, and this will be of length A. Second property is that the diagonals of the rhombus would be intersecting at 90 degrees. So all these angles will be 90 degree as well. And then finally these two diagonals will be bisecting each other. So it means that if I call this point as O, so AO will be equal to OC and OD will be equal to OB. So in this diagonal, in this rhombus, what all we have got is AO is equal to OC, OD is equals to OB, and AB equals to BC equals to CD equals to DA. Okay, what we need to prove over here is sum of the squares of the sides of a rhombus. So first of all, to prove, what we need to prove is to prove that AB square plus BC square plus CD square plus DA square is equal to the sum of the squares of its diagonals. It means equals to AC square plus BD square. And since we have already written this is A, this is A, this is A, this is A, this implies that what we need to prove is A square plus A square plus A square plus A square equals to AC square plus BD square. This means 4A square equals to AC square plus BD square. This is what eventually we need to prove. So now we can go in this triangle. In triangle BOC, angle O is 90 degree. So we can use Pythagoras theorem. So from Pythagoras theorem, what we can write over here is OC square plus OB square equals to BC square. So we got OC square plus OB square equals to BC square. So now let's write it over here. Now OC square is nothing but OC square. Can we write AC as OC plus AO? And since AO is equal to OC, can we write It's nothing but OC plus OC, that is nothing but 2OC. So can we write AC equals to 2OC or OC equals to AC by 2? Similarly, my BD is nothing but OB plus OD, and we know that OD equals to OB. This means that we can write OB plus OB, since OB equals to OD. This implies this is 2OB. This implies BD is nothing but 2OB. This implies OB is nothing but BD by 2. Now, if we call it 1, call it 2, and we call it 3, we can use 1, 2 and 3, basically 1 and 2 in 3. So what we can write over here is, from here we can write OC square plus OB square plus 2BC square, which is nothing but OC square is AC by 2 whole square, AC by 2 whole square, plus OB square is nothing but BD by 2 whole square, and BC square is nothing but A. BC is nothing but A, right? This is nothing but A square. Again, we can write, let's move it a little further up. So we can write AC square by, AC square by 4 plus BD square by 4 equals to A square, or we can write AC square plus BD square equals to 4A square. This is what we needed to prove, and this is proved. We could have written it in any other way as well. If you wanted to write it like AC square plus BD square, we could have also written A square plus A square plus A square plus A square, and this was nothing but all these sides are equal, so we could have written AB square plus BC square plus CD square plus DA square. So yeah, we could have written it in any ways. So let's look at this problem again and then try to understand what all we did. So in this problem, we used the property of Pythagoras theorem when we knew that this is going to be a right angle triangle. We also knew that this side, all these sides will be equal. We also knew that these the diagonals will be bisecting each other. These things could be proved as well if you try to look at these triangles. Since in rhombus these sides are parallel, this AD is parallel to BC, this angle is equal to this angle is equal to this angle, and both the angles are equal because they are like facing each other, right? These two angles are equal because these two lines are parallel, and this line is bisecting these two lines. So because of this angle is equal to this angle, right? So all these three angles are equal, so this means that this triangle is similar to this triangle. We could have also seen these two triangles are similar, and since this side is equal to this side, right, we know that all other sides will also be in the same ratio, so we could know that this side also will be equal to this side will also be equal to this side, then only this will be similar to this, right? So yeah, so this is already known to us, and we again tried proving it as well. So yeah, so this problem is done. Let's go to the next problem. Our next problem is this, which is, in this problem there is a figure given, and O is a point from which there are perpendicular which are dropped. So it's saying O is a point in the interior of a triangle ABC. OD is perpendicular to BC. This is perpendicular to BC. OE is perpendicular to AC. This is perpendicular to AC, and OF is perpendicular to AB. So OF is perpendicular to AB. We have to show that OA square plus OB square plus OC square equals, and there are multiple other things. So first of all, there is something which is given here is OA square, right? And we see that it is not like joined, so we don't have that side, right? So first of all, let's try to join this side OA, and similarly try to join OB and try to join OC. Rather, let me take the line so it will be drawn properly. So let me try to join OA, right? Try to join OB and try to join OC, right? Once we have joined these sides, what we can see over here is that these triangles now are looking like, of course, they are looking like a right angle triangle, and once we have a right angle triangle, we know that we can use Pythagoras theorem. So let's try to calculate first these entities. So let's take our LHS. LHS is nothing but OA square plus OB square plus OC square. So these are squares, while writing this has not come properly. These answer square minus OD square minus OE square minus OF square, right? So let's first write OA square. OA, when we go into this triangle OEA, so we can write OA square is nothing but OE square plus AE square, right? Similarly, OB square can be written as OD square plus BD square, and similarly we have to look at what we need to get. So we could have taken either this triangle or this triangle while calculating OC, but when we look at the other side, we see that there is another term which is CE square, right, and BD square and AF square. So we have to get CE square, right? So CE is in this triangle, so we will go into this triangle OEC, and in OEC what we can see here is OEC is OC square is nothing but OE square plus EC square, OE square plus EC square, and now we have other terms like OD square minus OE square minus OF square. So OD square is cancelled, OE square is cancelled, and you can see here what I have taken over here. This is not right. So OA square, what I have taken here is OA is OE and A, right? But I have OF over here, OF. So rather I should have gone into this triangle, right? So instead of writing this, so let me erase this part. So I should have taken what? I should have taken OF and AF. So I should have taken OF square plus AF square, right? So you could see that OF square is gone. Now what I am left with is AF square plus BD square plus EC square, right? So yeah, what we have to do is we have to look at the triangles and then use Pythagoras theorem to get to the entities which we want to, right? Now what is given over here is that AF square plus BD square plus C square, we need to prove A square plus CD square plus BF square. So we need to prove something like what is AF square plus BD square plus C square, and what is A square plus CD square plus BF square. So again, let's go into the triangle and then let's look at the triangles which we need to get. So we need to get AF is here, and then similarly we need to get BD, which is over here, and then we need to get CE, which is over here. So we know that these three triangles we need to go. So AF square, when we calculate in this triangle AFO, we can write AF square as nothing but, first let's write AF square plus BD square plus CE square, right? Now for AF, let's go into triangle AFO. AF square is, what is AF square? So if we go in triangle, let's write triangle AFO. In triangle AFO, what I have is AO square is nothing but AF square plus FO square, right? So my AF square is what? AF square is AO square minus FO square, right? So I can write here AO square minus FO square. Similarly, BD square I can write BO square minus OD square, BO square minus OD square plus CE square. CE I can write as OC square minus OE square, OC square minus OE square, right? So this is what I have got. Now I can rearrange these entities again. Why? Because I need to get AE square. When you look at AE, what I have is this triangle. AE is in this triangle. So if I get AO and OE, then I can get AE, right? So let's put AO square and OE square together, right? I'll take AO from here, OE from here. Similarly, what I need to get is CD square. CD square is where? Where is CD square? CD square is here. So CD I have to go into this triangle. So what I need to get? OC square minus OD square. So I have to get OC square minus OD square. So do we have OC square? Yes, I have OC square. Do I have OD square? Yes, I have OD square. So I'll put OC square minus OD square together. So what I'm left with is BO square minus OF square, right? Now look at this. AO square minus OE square. AO square minus OE square, nothing but AE square. So we'll write AE square. OC square minus OD square. OC square minus OD square is nothing but DC square. Yeah, I'll write DC square. Similarly, BO square minus OF square. BO minus OF is nothing but BF square. BF square. So what is that we have got? We have got AE square plus DC square plus BF square, which is nothing but RHS, right? This is also proved. This is also proved, right? So now let's go to the next question. What is my next question? Or let's try to understand this question again better so that we don't have any confusion. So what was given earlier to us was the figure wherein something was asked which was not joined, like OA square was not joined, OB square was not joined, OC square was not joined. So what did we do first was we joined all these lines together first. Once we did that, we could see that okay, these triangles are forming my right angle triangles, and there are multiple right angle triangles formed. So there are almost not actually exactly 6 right angle triangles formed. So this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. So there are 6 right angle triangles formed, and every triangle has got some properties which we need to grow over here. So in the first one, we started with OA square plus OB square plus OC square. So when we did OA square, we wrote it in terms of OE square plus AE square, and similarly for others. And when we wrote that, we saw that the entities were getting cancelled out, and we were left with something like RHS. In the next one, what we had to do was we had to start with one triangle and we had to rearrange the entities to get the another triangle. So in the first one, we started with this triangle. This was the first one. Then we started with this triangle. Then we started with the third one, C, and we ended up with calculating this triangle, and this triangle, because all these sides, when we rearranged, we got the other sides as well. So this is what all we did in these 2 examples. Now let's go to the next one. Next one is this example. This question is talking about there is a ladder 10 meter long which is reaching a window 8 meter above the ground. Find the distance of the foot of the ladder from the base of the wall. So if you have looked at a wooden ladder, you would see that the wooden ladder is generally like kept like this. So if this is the ladder and this is, say, your wall, so it will be standing like this because there are 2 ends to it and one has to support on the other. So this one will be on the floor. If this is your floor, this will be here and the next part will be here. So this is what it is given over here. What it is saying that there is a wall and of course there is a floor like this, and then there is a ladder which is 10 meter long which is reaching a window which is 8 meter above the ground. So if say this is your ladder, it's more like this, kind of ladder like this, it's like this ladder will be like this and your ladder is like this. Yeah, it's like this. So this ladder is 10 meter long. So this is what it is saying, and this is reaching a window. So there is a window over here which is like this. There is a window over here, and it is reaching a window which is like 8 meter above the ground. So what we need to find the distance of the foot of the ladder from the base of the wall. So we have to find this length, the foot of the ladder from the base of the wall. So if it is O, this is my A, this is my B. So what we need to find is OB, wherein O is given, and we can see that this is a right angle triangle. Your walls are generally at right angle, if you could see your walls, right? So again here we have to just use Pythagoras theorem. From Pythagoras theorem, we have to write Pythagoras theorem. What we know is OB square plus OB square plus OA square equals to AB square. So base square plus height square equals to hypotenuse, right? So OB square is not given, so OB square we write it like that. OA square is given, which is 8 square. AB square is given, which is 10 square. So now what we have is OB square, which is 100 minus 8 8 plus 64, which is again 36. So OB is square root of 36, which is nothing but 6. So this is 6 meter, and this is what will be your answer. So hopefully this problem is clear. This is very looks like a simple problem. So let's go to the next one. We'll go to the next one. What is my next problem? So a guy wire attached to a vertical pole of height 18 meter is 24 meter long and has a stake attached to the other end. How far from the base of the pole should the stake be given so that the wall will be taut? So what is given again here is, so there is, looks like there is a pole, which is like this. There is a pole, and what is there is that there is a wire which is attached to the vertical pole. So this pole has got some height, and there is a wire which is attached to this pole. So let's try it like this. So what it is saying is that there is a stake attached here. So there is something over here which is like this, and the wire is attached to this and to this end, these two ends. This is the vertical pole, and this is height is given, which is like 80 meter. And there this wire is attached to this end, and it is saying that the wire should be taut. It should be taut. So what it is saying that wire should not be like this. It should not be like this. It should not be a little curve or something like that. But rather it should be very very taut, right? And if you are if your stake is not very far, or it is here, so your line will be like this. So maybe your stake is over here somewhere, and when the stake is here, what will happen is that you draw this wire, and this wire will be like taut, and it will be attached like this. Alright, so this is how the wire is attached, and it is saying that this distance is almost how much it's given. It's given as this is not given, so we'll assume it as B. Alright, this is given 18 meter, and this wire length is given 24 meter. So again we can see this is gonna be a perpendicular. This pole is vertical. It is saying it's a vertical pole, and it is like driven in the ground. So from the ground, when you take this angle, this will be 90 degree, and let's call it O again. Let's call it A and call it B. So what we need to calculate again here is we have to calculate OB. So we can say that AB square is nothing but OB square plus OA square, again from Pythagoras theorem. Right? So AB square is given, which is the 24 square. AO square is given, which is 18 square. We need to calculate OB square, which I have just written. So OB square is 24 is 576, 8 18, it will be how much? 324, I guess. Let's calculate. I don't want to make a mistake. Right? And this is again 24. I'll just calculate. Right. So now we have got this. So 762, 725 and 532. Right. So OB square is square root of, OB, so OB equals to square root of 252. We can factorize it, we'll see how many factors are coming. So how do we factorize it? We'll first divide it with the minimal possible divisor, which is 2. We'll get 2, 126. Then we again divide it by 2. We got 2, 6 12, 2, 3. And then we got 9 or 3 will divide it by 3. We got 21. Then we divided by 3. Again we got 7. So what we got here is 2 square into 3 square into 7. So we can take out 2 square and 3 square. So we got 2 into 3 and then 7 remained inside. So this is nothing but 6 root 7. Yeah. So we got OB equals to 6 root 7 meter, and that will be your answer. Alright. So yeah, this is all we had to discuss in this lecture. We'll discuss other problems in the next lecture. Thank you. Thank you so much. Thank you so much for your time.